Good morning, everybody. We're going to just give it a few moments before we start the webinar today. Good morning, everybody. Just going to give it a few more moments while everyone is joining the session this morning. Okay then, so hello, good morning everyone, and welcome to day 4 of Innovation Week, a week which aims to celebrate and raise awareness of R&D agri-tech projects that Agri-EPI is supporting. The projects demonstrate the importance of collaboration across industry, science and academia to enable agri-tech innovation. So I'm Annabelle and I'll be your host for today's session. So just before we get underway with the presentations, there are just a few points I want to raise with you. So this webinar will be recorded and will be online for 1 hour and 15 minutes. All of the questions will be taken at the end and you can submit them as we go from the Zoom tool at the bottom of your screen. Please just, we'll be online for 1 hour and 15 minutes, but please just let us know in the chat where the company you're representing and where you're listening from. It'll be great to hear from you. Innovation Week is supported by Leighton, whose expert team work in close partnership with thousands of businesses each year to maximise the financial benefit they receive from R&D tax credits, grants and other innovation funding schemes. So for those of you who don't know, who is Agri-EPI Centre? So Agri-EPI's goals are to enable technological and digital transformation in agriculture, and we cover all of those agricultural sectors. Our aim is to achieve industry targets and improving food security and environmental sustainability. And we work with a number of stakeholders, government, academic, tech developers, retailers, engineers, farmers, and much, much more to enable agri-tech innovation through trials, asset usage, project management, technical advice, and membership. So without further ado, I'm going to hand over to Agri-EPI's chairman of the board, Vince Gillingham. Vince is founding director of Agri-EPI and also founded and commercialized well-known precision farming and digital farming brands in the UK, Europe, and Africa. He has continued passion for developing agri-tech businesses globally. At the heart of this, advancing agricultural research within the agri-tech sector. Integrated science and technology is at the heart of his objective. Over to you, Vince.
Thank you, Annabelle. Well, welcome all, and I hope we're going to have a very fruitful session discussing how agri-tech really touches the international scene, if you like, and I just wanted to share some of my experiences as an active person within the market and someone that's been through the whole journey of developing products and then growing businesses in different parts of the world. And it's sometimes a tough journey, but it's certainly a fulfilling journey. And I hope today's session will certainly give inspiration and some vision for yourself if you're here, watching the webinar to perhaps think about how you're structuring your own project, whether that be a commercial project or an R&D project or core science, how you can potentially take some of the things that I've learned from working on an international scale with agri-tech businesses. So just to give a brief background of myself, Annabelle mentioned I was one of the founding directors of Agri-EPI, founded in 2015, and in 2019 the board very kindly decided that I should be promoted to chairman. So I've been doing that for the last 2 years, and we're really trying to create an organization that delivers value to the market, and we're working as a company wide sort of objective to deliver real value into multiple sectors. They run across crops, livestock, aquaculture, robotics, and more. But it's something that we're trying to enable. We're trying to grow and help companies work with sort of leading academics and institutions to take their projects from an idea right the way through to an application on the ground, not just in the UK but internationally. And this is very much what this session will cover. So I've been through that whole journey. I've created a company. I've been through the Innovate UK and European Space Agency funding models, developing products with fantastic universities and academic institutions that have really helped me refine our product to be more relevant on the international stage. And I think it's important to highlight from the outset that when you're thinking internationally, there are unique challenges, and there are unique challenges that I didn't really foresee when we took this leap of faith, if you like, to try and grow a business outside of the UK. And you've got to think about the farmer often, and what a UK farmer looks like can be very, very different to a farmer, let's say in Africa or in China, or you're going to hear projects in Paraguay and New Zealand and China today, and in Kenya. So each farmer within those individual markets will be a different scale. There'll be a different size. They'll have different farm incomes. They'll be growing different crops, maybe different animals. They might have a very different supply chain that can support them in terms of agri-tech. So we've got to think more broadly than just the very connected nature of the UK and Europe and the US, where you have an awful lot of sort of established supply chains and distribution channels in place that can support these industries, and think about that in certain more extensive farming regions where you might have hundreds of kilometers between distribution networks. How do you manage that? How do you fill that gap with your product, and how do you make it relevant to the people that are farming that particular landscape? And the last thing I would just say, I mean, that there are real challenges but real gains to be made with international. I would say partner with local people. That was our key success. It was finding credible, hungry local people to understand the product, train them, really get them enthusiastic about the product and the science and how it can impact their particular market, and enable them to grow the business in their area. They will know the nuances when it comes to dealing with those farmers and institutions in those countries, and it can gain you an awful lot quickly from integrating international staff into your organization and ensuring that they understand the common goals and they buy into your vision as whether it's a product or a service. So certainly don't be put off, and I would encourage anyone who's thinking about taking their product internationally to certainly talk to Agri-EPI. We've got a great team, an international team that can help you, and honestly and frankly show you where there are gains to be made, and ensure that your pathway to success from the UK or from whichever country into another country is smoother than it may otherwise be. So I'm going to wrap up there. I thank Annabelle specifically for setting up the conference. I know it's been a fantastic week already, with some really interesting content. So I'll pass over and look forward to the session speakers that we've got. We've got Danie Swart, who's going to be talking about the Paraguay SmartFarm project. We've got Shamal Mohammed, who's going to be talking about the China and New Zealand smart farms. And then we've got Dr. Dennis Mujubi, who's talking about Finger Millet project in Kenya. So I'll pass on from there and look forward to questions later on.
Thank you so much, Vince, for that. Okay, so we're going to move on to our first live presentation. So it's from Danie. Danie is Zimbabwean born, and he has been working for AgSpace for the past 5 years under the Rhiza Africa brand. He's been conducting product sales, field research, collection, soil sampling operations in the Southern African region. Having grown up on a farm in Zimbabwe and working as general farm management in Zambia, he has in-depth knowledge of precision farming techniques and soil science knowledge. So we're going to go over to Danie now.
Hello, my name is Danie Swart from Rhiza, Africa in Zimbabwe. Today I will present a project entered into between Agri-EPI and AgSpace Agriculture in Uruguay for the 2019-2020 summer growing season. You may be wondering why I got involved in this project from Africa. It was because of the similarities in climates between Uruguay and Southern Africa, since we are both in the Southern Hemisphere, and we were looking at how we could link Africa data cross-hemisphere. The primary objective of the project was to prove that soil zoning and sampling could be carried out remotely using AgSpace technology. The secondary objective was to test the effectiveness of crop growth models developed for Africa working in South America. Working with the Vista Alagra SmartFarm, we were able to collect a data set to complete the project. In this presentation, I will discuss the process of the project and the transferability of data in agriculture. Grounded data. Using British technology to harness data solutions for soil fertility and food security. At AgSpace, we collect data using remote sense technology and couple this with ground truth data to build up a picture of what is happening on the ground. This starts from the soil right through to crop growth and harvesting. Our first step in the process is to harvest the data. For this project, we gathered 6,927 hectares of field boundary data. Within these boundaries, we have to identify the field names, cropping information for each field, and any relevant historical information about the fields. Mistakes at this stage can cause problems with communication, data entry, and analysis later on in the crop life cycle when using any kind of GIS data. Our second step is to individually map and zone the fields to create management zones within the fields. Essentially, this is creating smaller fields within a field which have just different physical and chemical properties. Using satellites, we can take images, enabling quick and cost-effective zone identification. Soil brightness algorithms, which look at soil variation on bare soil, clearly show varying properties in lands. Although it may not always be easy to accurately distinguish soil properties remotely, it is an efficient starting point for subsequent ground truthing. The amount of zones that are determined in a land will solely rely on the properties of those fields. A 1,661 hectare block of land was zoned for this project, as can be seen on the screen. The third step of harvesting data was to collect physical soil samples from the farm. This involved employing a local sampling team who received online training on zone sampling methodology. Once the samples were collected, they were sent to a local laboratory in Paraguay for chemical analysis. These results were sent back to AgSpace for entry into the system. A total of 509 189 hectares were sampled and analysed by the laboratory. Each zone has a label and tracking code, which helps with the identification of samples and links the sample into the contour program for further analysis. The fields which were sampled for this project were ready to be sampled at the time that sampling took place. Once we have completed the initial data harvesting, we then need to use the data for soil correction and fertility. This involves adding soil conditioners to fields such as lime for pH correction and fertilizers for NPK offtakes. These offtakes will vary by crop type, for example, high nitrogen in maize and low nitrogen in soybeans. Interpreting soil data can be an issue for many agronomists, especially with changes in geographic locations. Soil science literature can be seen to differ as well, as there are varying testing methods and reporting methods being used around the world, which some agronomists may not be aware of. The contour program uses an index system such as that found in the RB209. Soil analysis is interpreted from the testing type into the index system, which is easily color-coded and understood by farmers and agronomists alike. Nurturing the soil is the backbone of any precision farming manual. Here the aim is to apply the correct amount of nutrient into a soil zone for what is required by that specific zone. This is based on the chemical and physical data collected from the soil sampling and the literature available in a region for crop fertilization. For this project, African rule sets were applied to the soil data for fertilizer recommendations. As can be seen, there is a wide variation in the nutrient amounts applied for P and K fertilizers. The left column shows the recommended amount of nutrient, while the right column shows the levels of nutrient applied. Implementing the fertilizer recommendation is the final step to ensuring maximum crop success at the beginning stages of the crop life cycle. With variable rate application, there is not only a cost saving, which in this case was $10,000 on 589 hectares, there is also increased soil health and nutrition benefits, application efficiencies, and better general farming practices, all of which will result in yield and profitability increases. For this project, standard fertilization practices for Uruguay were used for fertilization of the crops using the local literature. Scaling the data. On this slide, we look at how data can be scaled to ensure maximum use of the data and technology during the growing cycle of the crop. Our first step was to assess the transferability of data from an African environment to a South African environment. To a South American environment. As can be seen, the growing seasons are very similar between Uruguay and South Africa, with some crops being planted earlier or later within the year. Generally, the summer crops and the winter crops are planted at the same times. Weather data also follows similar trends, although it was noted that there would be need for model calibration due to some variations in the weather data. The use of NDVI and chlorophyll imagery was used throughout the growing cycle of the crop on the full 6,927 hectares. Based on a traffic light system from red having poor growth to green having strong growth, this imagery enables farmers to identify variation in the crops and target weaker areas with image-based planning and mobile scouting app tools. As well as optical imagery, SAR data is also collected from the Sentinel-1 satellites. Models which have been ground-truthed in Zimbabwe and Zambia were applied to these farms to understand how they would compare in this region. Recording crop growth data remotely is a very powerful tool for the entire farming ecosystem. Two crop models were applied for this project on soybeans and maize. The maize model accurately determined crop growth stages. However, there was a limited amount of fields in the trial scope. The soybean model had technical issues with growth stage data, which was identified and rectified during the project. There was recognition that the growth stage calibration would need to be carried out, as the growth stages varied slightly on the ground as to what was seen remotely. Prediction data was inconclusive for maize due to the small number of maize fields mapped. The data had a positive trend for soybeans, with most fields being within 500 kgs of the observed yields. It is conclusive that with a mass historical data input, this model can be calibrated to accurately predict crop yields in the region. With various advancements in remote sensing capability over the past decade, it is clear it will play a vital role in food security in the future. The ability of remote sense data being able to predict, alert, and prevent issues from soil level, which the farmers correct, through to crop failure, which governments and corporations can foresee, is invaluable and requires adoption at all levels. Although remote sensing cannot completely replace the presence on the ground, the tools which are becoming available will determine success stories of farmers as our finite resources continue to deplete. Thanks to Agri-EPI for the chance to participate in this project. I thank you.
Thank you very, very much, Danie. Great to hear about the Paraguay SmartFarm project there. Okay, so we're now going to move across to Dr. Shamal Mohammed for insight into the China SmartFarm and New Zealand SmartFarm projects. So Dr. Shamal Mohammed is a leading expert in digital agriculture with a strong passion for transforming the industry by developing novel and practical solutions using smart technologies to help farmers and producers optimize food production and minimize adverse environmental impacts. Over to you, Shamal. We can see your screen.
Great, thanks, Annabelle, and good morning, everyone. My name is Shamal Mohammed. I'm a Chief Technical Officer at Agri-EPI, and what I would like to do this morning is just to share with you our SmartFarm initiative in both China as well as New Zealand. So we started with the China project a couple of years ago, probably it's more than a couple of years now. was part of the UK and China joint strategy for science and technology, and that was as part of that strategy and collaboration between the two countries. There was a flagship challenge around agriculture and agriculture technology, which is basically trying to work with Chinese partners and as well as the UK agri-tech sector to build projects that demonstrate the advancement of the UK capability in agri-tech and helping improving productivity, but also the sustainability of food production system in China. So as part of that project, we have funding from Innovate UK and working closely with the Ministry of Science and Technology in China. And our partners, key partners in China is NERCITA, which is the Center for Technology and Agriculture Engineering. So the project partners include officials from China and as well as the UK on a government side, but also in terms of the industry and universities. We have Strathclyde, James Hutton in the UK, Soil Essential and RDS, which provide a technology for building the SmartFarm demonstration in China. And the idea behind this initiative is not only one-off project, it's actually a 4-stage SmartFarm approach. And then we started with the SmartFarm 1.0 back in 2019. And as part of the first stage of the project, what we trying to do is bring in some of the UK technology. So as I mentioned, we got RDS yield monitoring technology to map the yield and productivity within the field. We have Soil Essential providing their farm data platform. Core, Strathclyde University demonstrated some of their robotic capability to understand the sort of the variation in the soil analysis and also to help farmers to understand some of the limitation in terms of productivity. Basically, the project we're looking at variable rate application of nitrogen specifically. So we tried and trials different rate of nitrogen, looking at the yield map and looking at some of the satellite imageries in order to understand the productivity, also building some new ways of looking at fertilizer and the fertilizer application to minimize the environmental impact, but also improve the productivity. And this project basically demonstrated the power of data and especially the remote sensing data and satellite data to be able to monitor and understand the crop growth throughout the season. So it's not only one-off sort of imagery. It would allow the farmers and the producers to look at the crop at a different stage of the growing season, understanding some of this limitation and making decisions to improve it throughout the season. As you can see, it's an international project. We went there, we worked with our partners in China. We understand some of the difficulties and limitations in order to, it's not about just transferring the technology, but also understanding the challenges and limitations facing those countries as well. As I mentioned, Strathclyde University, they demonstrated one of their agri-rover system, which is a robotic solution for analyzing the soil real time. So the robots has a lab taking a sample in real time, analyzing the soil composition and then feeding this back into a data system to kind of understand the variability within the field. And that's really important to help making some decisions on soil nitrogen application, for example. Also, the Strathclyde University, they demonstrated their robotic harvesting arm for tomatoes in greenhouses, and that was another sort of demonstration of agri-tech, UK agri-tech capabilities in China, and there are a follow-up projects is trying to take this into a more commercial stage as well. This is the team. The way we work with our partners is a collaboration, is bringing our capability and understanding their capability as well, and trying to build a much more integrated solution. In the same time, to be able to open up a sort of a market for the UK agri-tech companies as well. We finished and we demonstrated the success of the SmartFarm 1.0. In the same time, we had a discussion with Tianjin Food Group around some of the challenges on animal welfare, disease detections, and helping with the optimizing their environmental impact. So this is almost a between different stage of the SmartFarm. So we call the SmartFarm 1.5. And the whole purpose of this project is to demonstrate the UK technologies to predict and to understand the disease in a very early stages in pig sector. We partnered with Tianjin Food Group, started last year just before COVID, and obviously with the COVID and all this sort of restriction on travel, it was really challenging to kind of progress with the project, but we've been able to work with them and using various different options to make the start of the project. So we successfully sent all the equipment there, done a lot of online training around installations and how we can start capturing some of the data set. So we have three key UK partners, Robo Scientific, looking at the detection of disease using their air sampling and looking at some of the organic volatile aspect. They already developed this technology in other sectors. Greengage providing environmental and animal behavior sensors, and Innovent with their 3D camera technology. So Robotus Scientific, they done some work in poultry, especially in chicken, and looking at the influenza. For example, you can see in this graph, they can clearly identify influenza just by analyzing the air sample. So we're deploying this technology in China and then taking air samples in different, well, in a healthy pig as well as a infected pig, and then trying to build this sort of algorithm for detecting disease at the early stages. Innovent, obviously they are developing this 3D camera capability to detect any changes in animal activities and behaviors, and understanding if there is any disease, can we pick it up by looking at some of the animal movement. So we're deploying this in the same farm as well. And the last one is a Greengage, basically looking at some of the animal welfare sensors. So we're deploying these sensors as well. So as you can see, we brought three different companies with the three different capabilities. And the idea is by joining all these sensors and technologies, we can build an integrated system by looking at the air sample, the 3D cameras, and all these animal welfare sensors. So we can demonstrate we were able to detect some of the disease at a very early stages, and that would help Tianjin Food Group to minimize the impact on animal welfare, on productivity, but also on some of the environmental aspect of their food production system as well. So this is an ongoing project, is already started, as I mentioned, and we are hoping that we're going to collect data in the next couple of months and demonstrate the results into our key stakeholders. Sorry. So that's the China project. We also engage in New Zealand, and this is more looking at the capability of big data and data collections and analytics in terms of improving animal production, and as well as minimizing the environmental impact, like of a greenhouse gas emission. So as you can see, there are multiple partners there. And the aim of the project is to, as I mentioned, to kind of optimize the productivity by capturing as much as data from the feed, from the animal movement and animal behavior to maximize productivity, to increase the uptake of feed, but also to minimize the impact on the environment and reducing greenhouse gas emissions for both dairy as well as beef. There are UK partners which we represent, and we have a New Zealand partners as well. So we feed into a big data platform and applying different sort of models and building applications for farmers, a decision support system, so they can make decisions to improve their productivity, but also looking at some sort of publications and then helping the advancement in terms of the science and research as well. These are just a few examples of the results came in. So we successfully built this sort of a model for the feed intake, but also looking at some of the colors and activities of the animals, and then looking at the impact of the heat stress, for example, so you can clearly identify what actually is going on under different production systems. So I think this is my last slide, and I'll stop here, and I'm happy to take any questions later on. Thank you.
Thank you very much, Shamal. Thank you. So remember to just keep submitting your questions, and we will come to those at the end for a panel discussion. So I am now delighted to hand over to Dr. Dennis Majubi. Dennis is a geneticist with a PhD in animal science from the University of Alberta, Edmonton, Canada. He is the CEO of Isami Limited, an agri-tech company based in Nairobi, Kenya. At Isami, he is using ICT, phenomics, and informatics to collect performance data, provide real-time actionable feedback, and link farmers to markets. Dennis' passions include design and development of channels for enhanced uptake of best farming practices, as well as appropriate technology transfer and smallholder farming systems. So Dennis, we're delighted to have you with us today, and we can see your screen. Over to you.
Thank you so much, Annabelle. I'm gonna put my video off just so that I can get good audio. Yeah. So Isami Limited is an agri-tech company in Nairobi, Kenya, and we link farmers to markets. As it has been mentioned, the market here perhaps is not as advanced as in other countries. And so when you endeavor to link farmers to market, there are many other things that you must consider. And that's why our model is really end-to-end. Our project has a long title, leveraging remote sensing and ICT to facilitate yield maximization, structured trading, and inclusive value chain participation. And that sort of gives you an idea of the breadth of what we are trying to undertake in this project. The partners, I'm going to mention the partners who are delivering this project a little bit later in the presentation. Why Finger Millet? So our project is about Finger Millet. The question is, why are we focusing on this crop? This crop is important. It's very critical for us because number one, it's a climate smart crop because there's a lot of climate variation. And given that our farmers depend on rain-fed agriculture, working with a crop that is well adapted to the environment is critical. And so Finger Millet is actually drought tolerant. And it is one of those we call a forgotten food. It's an orphan crop because most people have abandoned cultivation of this crop to go to maize and wheat and those other things. Most importantly, it can thrive under climate smart approaches. The second reason why this crop is important is because it can be considered as a nutraceutical. I mean, its health benefits are immense, despite the fact that people have moved to maize largely here in Kenya. I think there's a lot that can be obtained from Finger Millet, from it being a natural source of vitamin D packed with calcium, which is very critical for bone health for both young infants and pregnant mothers. It is densely packed with micronutrients. And of course, it is gluten-free. And this is an emerging trend where people are looking for gluten-free products. So makes this a very important crop. And finally, we chose this crop because of its commercialization potential. We import a lot of it in the country to utilize, mostly as a flour to make porridge. But there is a lot that can be done with it, from breakfast cereal and other things. It is largely informally traded. He has huge export potential, but most importantly, it is grown under subsistence production. So working with this crop provides us a huge scale, a huge plane to scale whatever activities are. And we are working across different segments of the value chain. We are targeting farmers for the production activities. We are targeting processors for offtake of the crop, but we are also targeting consumers directly so that they can be able to grow markets for us because of the health benefits. So we are targeting consumers that are health conscious, and especially given the rates of malnutrition in our region, this is essential for us. So it is an end-to-end model that we are working with here. Okay, so what's the problem that we are trying to solve here? I must say that this project is in early days, and so much of what I'm going to be discussing are things that are actually ongoing. We are, I think, 6 months in, and the problem that we are setting out to solve is the fact that a lot of our farmers depend on rainfall as the main source of water for their crops. And because of the increasing changing patterns of weather, it becomes very difficult to know when to plant and when not to. And so application of these precision agriculture techniques would actually be of immense benefit to farmers, not only knowing which soils can be able to carry the crop, but also knowing when to grow and things like that. So we want a sort of a data-driven agronomic advisory mechanism available to our smallholder farmers. The other thing is that because we are working with a very informal value chain, you find that most of the value is appropriated by middlemen. Yeah. And this means that the farmer toils in the land but does not get the benefit back. And so we are trying to set up a system for forward contracting so that each and every farmer has a contract farming arrangement that guarantees markets for them. Then ultimately, the information flows within the system are not optimal. And this means that whoever has information is benefiting at the expense of the farmers. So we want to be able to provide them farmers tools that allow them to get information in real time. So how are we doing this? We are doing this by integrating two value chains. So we've got the grains value chain, the finger millet, and then we've got the poultry. And the poultry sort of stabilizes incomes for the farmers, but also ensures that in the event that you've got some waste grain, they can serve as feed for the chicken. So a nutrient recycling mechanism that makes the system much more sustainable going forward. We are attacking 4 areas that we think if we can be able to provide solutions, can be able to make the system resilient and sustainable in the long term. Number one, we are working on mechanisms to ensure that the farmers have got the tools they need to be able to farm. And we're talking about finding financing institutions that can be able to provide input loans to farmers and also provide social benefits from crop insurance to emergency loans that give the farmer the presence of mind to focus on production, because that's one of the biggest problems when you're working with subsistence farms. The other thing that we're providing is customized training. Much of Africa, governments have left training. There's something that's in play that is called demand-based agronomy, or extension services, which really are not working very well. So we have to find a mechanism to provide training to farmers. So as part of the project, we are also providing training services to the farmers. I think where we are playing the most, where Agri-EPI and the other partners are coming in a large way, is technology and mechanization. Most of our farmers, subsistence, use human labor, and we want to transition them to a bit to be working in a more predictable way, where they can use precision agriculture platform, remote sensing, soil testing to be able to actually maximize the yields and know when to plant. And this we are doing, Agri-EPI is leading on developing a remote sensing platform that will allow us to be able to see what the soils look like, what the nutritional profiles of the soil feeding arrangements should look like. So we are able to use remote sensing to profile the soils before farmers plant. We are also working on building market platforms. Through this Usomi Ruby platform, which is a market access system that is able to aggregate farmers who are sparsely distributed, so that the economies of scale can come to play and they can be able to get a better deal. So we've built this platform and we are increasingly improving it so that farmers can be looked at as one big whole, because market players don't like the way the farmers are dispersed. Then the last thing is we are looking at options of mechanization. What tools should the farmers be using for seed placement? You're dealing with finger millet, which is a very tiny seed. How do you do that? Because the current mechanisms of hand sowing provides a lot of work when it comes to weeding. We are thinking about post-harvest. How do you harvest the crop? How do you thresh it? Many people don't like planting finger millet because the workload when it comes to the harvesting is heavy. So how can we bring mini combine harvesters? How can we get threshers and winnowers to make the post-harvesting much easier? And of course, there's issues to do with structured markets, where we are putting up storage facilities. So we are renting out aggregation centers where farmers can bring the crop and we can store it appropriately, and then link those farmers to market. So those are the solutions we are working on this project. And the partners who are delivering the project is Agri-EPI Centre. We have Newscape Agrosystems who are focusing on soil nutrition and agronomy, building demos where farmers can come to see best practices. We've got Strathmore University here in Nairobi, Kenya, who are responsible to look at the social impact of what we are doing, if they are appropriate, given the context on the ground. Harper Adams are working also on the agronomy solutions, especially mechanization options and crop establishment. How do we do that sustainably, profitably for the farmers? And of course, Agri-EPI is leading on issues to do with remote sensing and setting up a sort of weather observatory service of some kind, so that we can have some sort of data that can inform farmers when to plant, when to harvest, and things like that. And the funding is coming from Innovate UK. Very quickly, and I'll not dwell on this. This is our model, offering an end-to-end solution. We want to move farmers from tilling less than an acre. Most of them do quarter and half an acre. We want to increase that land size. And you realize that those small land sizes are actually a very big problem when you want to do remote sensing and things like that. So you have a very small piece of land and you want to be able to predict certain things. The resolution of the satellite imagery data you get from, say, Sentinel-1 is not fine enough to help you to do some of these things. So those are some of the issues we're grappling with. We want to increase the yield from 600 kilos to 2 tons. We know it is possible because some of our farmers are actually getting close to that yield. And of course, when you look on the other side, you've got the data. We want to really be tech-centric so that we are able to do data-driven agriculture. And of course, using data system, handheld devices and apps that we've developed, with a network of people called the commodity supply specialists who are out there in the field, ground truthing data, collecting field data that then is linked to the satellite imagery data to provide the ground truthing that is needed for the system to work. So this is the plan that we have. This is what we are set out to do, and it is ongoing right now. So far, as you can see, those are ladies out there in the field who are tilling the land before the planting. And those are the two productivity tools that we've developed that are going to drive this sort of information platform for the new system. On top of this, apart from the grain part of it, as the farmers are waiting for the crop to grow, they need to be able to be sort of safeguarded from shocks. They need cash flow to be stabilized. And so we are also integrating indigenous poultry farming in this, such that in between the cropping cycles, you've got farmers having income through indigenous poultry. This is a strategy, anybody who's done contract farming in Africa, one of your biggest dangers is side selling. And to mitigate some of those things, you want something that is bringing constant cash flow to the farmer so that temptation is minimized. And we are using poultry to do that. Beyond a cash flow stabilization strategy, it also is a source of food for the farmers. And therefore, this paradox we keep on working of hungry farmers, we're also trying to mitigate that. I think so far we are doing well in the project. As you can see on the left, that's the level where the crop has been. It was planted somewhere towards the end of March, beginning of April. So we've got perhaps another 2 months before planting happens. And we are in the middle of the project. Different things are happening related to building the platforms, related to testing data analytics on remote sensing. We are yet to go to the field to collect field boundary maps for all the farmers, so that then the system can actually be put in place. But so far so good. We believe that we should be able to get the outputs that the project envisioned. So thank you very much. In case of any questions, I'll be glad to answer them.
Very much, Dennis. Okay, so now we are going to go across to some questions. So if all the panelists could bring their videos back on, and we will start to take some questions that have been coming in. Right. We can have everyone's videos back on. Brilliant. Okay, so we have our first question, which has come in today. And that is across to you, Danie. So it's what benefits did the Paraguay SmartFarm receive from the remote sensing platform, the financial savings, how much improved understanding of the soil health as well?
I think as a general rule of thumb, we didn't actually do a lot of cost benefits just because of the differences in the soil literature. So the ways that we fertilizing in Africa and the ways that are fertilizing in Paraguay are very, very different. But what was found was that the farmers could get a very good insight into what was actually happening in their fields, what their soil variations were doing, and how they could look at those soil variations in a different way, away from your conventional sampling methods to the zone sampling method. So I think it was more of an insightful thing and more of an educational journey that we went on.
And how do soil testing methods differ, and what should agronomists be aware to look out for?
So if we take the example of pH and phosphorus, so there are 3 different types soil of pH testing that we use in Africa. So there's water testing, KCl testing, and calcium carbonate testing. So each one of these comes back with a different value, and if the agronomist is not aware of which testing method has been used, just on your liming, you can recommend the incorrect rates on a recommendation. For phosphorus, again, we've got 3 different types, and then between Zimbabwe and South Africa, we also report an elemental and oxide. So there's huge variation when reporting on soil science comes from laboratories that people need to be aware of.
And just sorry, Danie, staying with you now, but how did you develop the crop growth models in Africa, and what technology was being used?
So the crop growth models are developed through ground truth data. So we collect 3 years of ground truth data on a crop. And that is with certain protocols going into a field weekly. So we go into a field weekly, gain certain protocols from the crop, and feed that back into our models. From there, we're using weather data, weather satellites, optical satellites, and SAR satellites through machine learning to develop the models for growth models and yield prediction.
Right, so I'm going to go across to Shamal now. So we've had a question that comes in that's, do you think robotics are as relevant in China? And when do you think we'll see robotics in the UK field?
Oh, that's a really good question. Obviously, this technology has a huge potential in the UK as well as, globally as well. My view is, robotics is probably when people see a little robot, running around the field, but also is much wider than that, is the automation and the use of the sensors and technology to do various different operations. But in a high value crop, especially in the UK and globally, has a huge potential, and you can see probably in the next couple of years and now, basically, there are many robotic solutions helping farmers to do various different processes and applications. Harvesting high value crop is a quite advanced, especially in strawberries and top fruit as well. We've been engaged with the industry in the last 15 months, especially after COVID and obviously Brexit and lack of labor in those industry. It will push the development of robotic solutions massively, and we've seen the changes even within the policy side as well. So you would see, we will see some sort of a funding and support from DEFRA, for example, for some of these robotic solutions in the next 3-4 years.
Well, we're with you now. So what's next in terms of the SmartFarm? How will this develop and support agri-tech businesses?
You mean SmartFarm in globally, or is it in the UK?
Globally.
Yeah, well, our ambition is to build this SmartFarm platform in many countries. As we demonstrated today, we have a few ongoing SmartFarm, but this is a fantastic platform for showcasing the capability of a UK agri-tech on a global market, and then showcasing what we can do and how we can help them to achieve their food security, but also to be environmentally more sustainable, because we are living in a global world, and the food supply chain is global. So we need to make sure the production system is sustainable and productive, but also helping the UK agri-tech sectors to explore an international market as well. So I think what I see is more of these sort of activities, and Agri-EPI is playing an important role, and then we're trying to expand into a different other countries as well. But all of that is depend on funding and someone kind of helping us to build that sort of a collaboration internationally.
That theme as well. So I'm going to head this over to Vince now. So what are the top 3 tips that you can suggest for the UK agri-tech businesses to succeed in international markets?
Okay. I think the three key things that I have learned through my particular journey is, one, to conduct very thorough market research. So don't be naive to think that your product that you've developed in the UK is relevant in another country, because you will very quickly fail if you believe that something designed for the UK will fit into a market. You should be finding people like Danie, like Dennis, and like Shamal to help you understand how your product can fit and add value in that market. If you don't do that, you're almost certainly going to fail. So that is the most important. Number one is do thorough market research, go to the country and talk to the people who really understand the market and understand the complexity and the market need. Then number two, I would say, would be to employ local people. Once you've gone through the journey of understanding the market, is to make that leap of faith and create a footprint in the country that you're willing to invest in. Local people need to be bought into the vision of your organization. They need to understand the project and the product, and they need to really be enthusiastic about the delivery of that. Without a team on the ground who understand and in many cases can speak the local language and can help you interpret feedback, you're really stuck. And that's another sort of key lesson that I learned, was that finding local people in the markets that we grew into was the key to getting that out on the ground and financial success. Because otherwise you're often, a language barrier, for example, is often in the way. And finally, I would say, contact Agri-EPI. I mean, the footprint that we have as an organization is now global. Whether it's trying to find finance for a project, whether that be through government grants or investment from funds and other bits and pieces, we can help you springboard your product that may be developed in the UK or maybe developed somewhere else in the world and enter it into a new market and help you go through that journey together. That's very much what Agri-EPI is about creating that framework to help you deliver your technology into a new environment. And not just from a business to business relationship, but also Agri-EPI has links into governments. So through DIT, we can help, if there are barriers to entry through government, red tape or legislation that you need to understand. Again, we've got the skills internally to break that down. And as the demonstration or SmartFarm network increases globally, you can use that network as well to demonstrate your technology and show, if you like, within a real farm environment how that technology can work for that country. So they're the three things. Conduct your market research. Number one, very important. Employ local people and engage them with your company. And three, and it's probably the wrong way around, it should probably go before one, but is get in contact with Agri-EPI to really help you on a roadmap, a journey to get you to the idea, I want to go international, to actually get you to international. There are a huge amount of tools that EPI can push you in the right direction to make that journey a safe one and a prosperous one.
And so we've got team at agri-epicentre.com in the chat if you do want to get in touch as well. Just a few more moments for some questions as well. So I'm going to go across to Dennis now. And what is your vision and end plan for commercialization of the project?
Okay, so the beauty of the project we are doing with Agri-EPI and Harper Adams is really that technology package that we are looking for, because for us to be able to maximize productivity for the farmers and extract the benefit that the farmers will have, is we need that technology package. And I think it's actually a stroke of luck that we partnered with Agri-EPI and Harper Adams, because you've got capabilities in these things. And we see that the vision we have, we actually going to be able to do it. What are we looking for? We want to be able to get an effective remote sensing platform that works for our farmers. And we want to co-create this. We don't want just to ingest somebody else's technology. We want to be part of the creation. And that's why this collaboration is important. That capacity building is critical for us. The second thing that we are looking for is to be able to have create models. I had, when Danie was speaking, I was very intrigued because he was talking about the crop models for maize and soya. And I was sitting there and saying, I need some of those models for finger millet. And I know we are moving towards that. So once we are able to get growth models and yield prediction models for finger millet, we'll be closer to our goals. And then lastly, the mechanization part of it. I think mechanization is critical. A lot of our farming happens using manual systems. We need to move beyond that. And when Shamal was talking about what he was doing in the smart farms in China, I was very interested. Now, I mean, we are not going to go to that level. I mean, we are not yet there to be able to go to that level. But how mini-scale mechanization, small tools, what can we be able to get? So those are the things we are looking as we do this project. We have an eye towards those things. We want to be able to put those things in place so that we can start increasing the efficiency. So commercialization for us will take a while, right? There's so many things to put in place. So we have a long way to go before we get to really commercializing all the outputs of the project.
Shamal, is there anything to add to that there? You just came off mute.
Yes. Well, I mean, just to add what Dennis was saying, I think that's really important for anyone trying to explore international market. That engagement and understanding the challenges, as Vince mentioned as well, is really important, because sometimes you might gain a short-term gain by just selling your technology, your services. But if you are not engaging, that might not be a long-term business for you. So I think understanding the challenge facing those countries and how you're not just transferring the technology, but also you're transferring the knowledge of how to use the technology, how you adapt it to fit with their sort of challenges, their limitation in terms of, or the structure of the farm, and some of the the physical differences between how you develop the technology here in case it might be different in Africa or Asia or any other country. So I think understanding that is really important, because ultimately, for those countries, buying technology or getting a new technology is an easy part. And this is almost, I'm using this analogy a lot. It's like, you can buy any car if you have money. The challenge is how you can use it and maintain it. And I think that need a local knowledge and local understanding. So, getting these technologies and all these robotics and anything is available in the UK, in those countries, that's the easy part. So all the companies and governments and other agencies can invest. But the question is how we work with them, understanding their problems and their requirement, their needs, in order to be able to kind of engage with them in the long term. And that's why Agri-EPI is building this SmartFarm initiative. It's not a short-term engagement. We would like to engage in the longer term and building that sort of a bridge between the UK capabilities and the needs and the requirement from those countries as well. So absolutely. Thank you.
I'm just going to do a final question to everybody on today's panel. So it is around what are the challenges, if any, of some of these projects being implemented? So if I go across to you, Dennis, first.
Okay, yeah, there's a lot of challenges. What we are trying to do as a small business, we are trying to do government function, we are trying to do NGO functions, we've all boxed into one small little project, and it's really challenging. I think one of the ones which has really been debilitating for us is that you realize, to be able to do this, the farmers need to be able to have the resources to be able to get the technologies we are proposing for them. And the financing landscape for agriculture in Africa as a whole is really not that good. And so you find some of these things have been the preserve of NGOs and donors, but we want a commercial model. And so that shift mindset of smallholder farmers to this commercial model where they need to invest significantly in new technology, new seed, new fertilizer, and all these things. It's quite difficult. The other thing is also assembling the skills and expertise, right? To have the boots on the ground, like Vince said, having people on the ground who can actually execute at the level where you require them to execute to achieve your goals. For us has been a challenge because good talent costs good money. So it's a real challenge. I think those two for now are the biggest challenges we have.
Danie.
I think just from our side, complexity of data is one of the biggest challenges, and especially when you're moving from one region to another region. You know, you get changes in varieties, you get changes in growing terms and cycles, and when you're developing tech that is looking at different growth stages and predictive models, you're always going to get variation according to what's happening on the ground. So, you know, to keep up and really understand that complexity of the data is a major challenge.
Sorry, Shamal, just any challenges in implementing the China SmartFarm project?
Yes, well, I agree with all the comments from Dennis's and Danie and Vince. I think I'm probably highlighting a few other little things. So, communication and understanding the way the other countries operate in terms of I will take an example of a project. So their protocol of, for example, trialing things, it might be different from the way we do things here in the UK. So understanding that little sort of a differences is a different country, you have a different culture, they are having a different protocol, different system. So understanding those little things, it would help massively. And then obviously understanding the rules and regulations around some of the issues Danie mentioned around data, which is massively important, especially for us in China. So you need to understand all these sort of little things, which is probably not being highlighted as much, but it make a big difference on a daily basis when you are engaging with the international partners. Things like differences in the time zone, when you're going to have your meetings, who is translating what, and what's the translation is, how much is actually meaning what they're saying. So all of that little things is quite important in building a proper and long-term relationship with the international partners. Thank you.
Right then, those are all our questions that have come in now live. So we'll be happy to take them after the event as well. If you're watching the recording or you've sent it on to any of your colleagues, we can facilitate introductions after this event. So thank you to our speakers, our presenters. Thank you to Vince as well for a great opening presentation as well. So this is day 4 out of Innovation Week. Our last day is tomorrow about aquaculture projects. So we hope you can join us then. Thanks to Leighton as well for supporting this week, and we look forward to hearing more from all of the attendees and engaging with us going forward. Goodbye all and have a great day.